so I'm going to move on then to the next part. Real quick show of thumbs here. I'm going to just give me a thumbs up. Who has gone through section 1 already? It's okay if you haven't. All right. Give me a thumbs up if you like have looked at it. Like even if you haven't done all of it. Like it's like I breezed it. Okay, good. Oh look, you guys are all getting thumbs up now. Awesome. No worries if you haven't yet, right? Because like you guys will get through it and everything like that. So basically the main thing of section 1, if you go through it, is basically the Python basics. And so in general, I think most of you guys have now had at least some basic experience with Python and writing some Python. But of course, if you're feeling like, hey, like, I don't know if I'm exactly the best at Python, stuff like that, you will definitely learn a whole lot. I guarantee you within like, a few months from now, you will be at like that, at the very least intermediate level where you're going to be pretty familiar with Python and using it. Pretty much that's exclusively what we're going to use as a data scientist, unless we're doing something very specific. But so it's good to know some basic like best practices. So just a quick like thumbs up, like does anyone have a computer science background already? Okay, so I see a couple people hit thumbs up, maybe some kind of shaky a little bit, that's okay. Even if it's like, for sometimes, for example, like I've had people say, oh, like the only programming language I had was back like when I was in university in C, like C or something, even like, I don't think I've had anyone say anything too out there. But know that basically like, if you don't have as much programming experience, this might feel kind of new. For those of you guys who do have programming experience, especially if it's not in Python, you'll be familiar with it, but you'll notice that Python's a little bit different, and we'll talk about some of those nuances too. Okay, so one thing about code is that basically, in those people who write code a lot, is that you read it more than you write it. And I will emphasize this, is that in general, is that I will spend more time thinking about my code than writing my code. And I think that's a good thing. Usually what happens is when people first learn about coding, they're just going to try pushing things like writing code in there and like trying it, and it's not working. And sometimes it's good to take a step back and plan out, okay, what am I trying to achieve? Your code basically is a tool. Python is a tool for you to do something. And one thing about computers is that the great thing about them is that they do exactly what you tell them. The bad thing about it is that they do exactly what you tell them. So you can get some really weird issues and stuff like this. And that's where it really helps to kind of like, my big suggestion for you, especially if you're feeling kind of frustrated sometimes you're writing code, is take a second back, think about like what you're trying to do and try to look at it in a new eye like that. And this is where also using someone else, like say, hey, can you take a quick check of my code? Can be really useful, because maybe you say, oh, you're just missing this part right here. Or it's like, oh, I'm not sure why you're doing this part. So that's kind of like my overall like suggestion as you guys are doing code. Some nice best practices to know for Python specifically is PEP 8, the Python enhancement proposals. So you might see this PEP 8 and different PEPs and stuff like this. But basically this is a structure of saying, how you should write your code. I will tell you is that I don't think I know a single person in the whole world, including the person like who wrote PEP 8, that absolutely follows these steps and everything like that. But they're good guidelines. And so the general basically idea, and you can see how long this thing is, like these are all kind of like the ideas of like how you keep your code nice and easy to read and stuff like that and simple. People will break the rules sometimes, that's perfectly fine. But I suggest, as suggested reading, that you should go through this and just read this through. One thing, if anyone knows tabs versus spaces, use spaces. Like this is one of those things in Python that if you use tabs, like in other programming languages, if you're used to use other programming languages, it doesn't really matter. In Python, you can get some weird spots where like you start banging your head against the wall, saying, what's going on? And you realize you use a tab instead of a space. So use spaces. If you have been using an IDE like Atom, Sublime Text, VS Code, there are options to also make it so that whenever you tab, it actually tabs 4 spaces, and the standard is 4 spaces. So just kind of know that kind of little small stuff. But anyway, yeah, so I suggest, going through this, reading it through. This is again on the repo up on GitHub and everything like that. And I'll point to you guys maybe after this study group and everything. But anyway, PEP 8 is a really nice thing. Other standards you should kind of think about, like that you can kind of check out. This is the Google Python style guide. So I believe this is what actually Google uses internally as like how they write their Python code. So you can read this through too. And you'll notice that some of it matches with PEP 8, some of it doesn't match with PEP 8. And that just depends on your who you're working with. But the main thing I would say is make your thing readable, make it understandable. If you have this really complicated thing, don't make it complicated. Like, spread it out a little bit. See if you can make it more easily understood. I would rather have code. I would rather read codes from someone else. Remember, because sometimes you were working with other data scientists that look like takes more steps, takes more lines, basically to do multiple steps than someone who tries to do it all in one line and this really complicated mess. I used to work, I don't know if I gave you guys background a little bit, my background, but I was working as a basically software developer. And one of the things I had, like, basically to sum it up, is that someone wrote this code and said, hey, can you convert this code into this new format? And I was reading their stuff through and I'm like, I don't understand, like, I can read it, I can understand it, but it was just so like convoluted and like it wasn't clear. And we'll talk about comments and stuff like this. There were no comments. There was no explanation of why the code worked the way it did. And this is with a credit union and basically with finances. And they said, like, and I told them, I said, do you guys know what it's doing? Like what it's supposed to do? It's like, well, not exactly. And we're like, that's going to be a problem because I can implement this, but like, this is like more for like compliance, like reasons and stuff like this. It's like, if they don't know what's going on, they can get in huge trouble of this kind of stuff. So my big thing is, maybe you don't have that high end, like not high end, but like that really big concern, but making it readable is going to be easier for you and for others. And also I like to say, even if you work it on yourself, I always pretend that I'm working with a team, even if it's my own code, and I'm working with future Victor and past Victor, because future Victor always looks at past Victor stuff and says, what the heck was you thinking? Like, I have no clue what's going on. And you'd be surprised. Like, you might think like, oh yes, like, yeah, if it happens like a few months later, you might forget what's going on. No, I literally like would go to lunch and come back and say, what was I doing? Like, I don't even know. So this is where really documenting your stuff, pretend you're working with someone else, is going to help you in the long run as well. Okay. So good practices overall, again, Pepe's a good one to talk about stuff like this, but good practices, readability, no magic numbers. Do you guys know what I mean by no magic numbers? All right, so magic numbers is when you basically just put a number in there, but you don't have an explanation why. It's like 12, and you're like, but why did you put the number 12 in here? You want to document things. So for example, if we have, let's say like, I'm going to try to make something up on the fly. This is not going to go well, just to let you guys know. But let's say like x equals, 3 times, I don't know, let's say n. Okay, and I have like n equals 5, right? And let's say this is going to describe some equation or something like that. And I just have this in here. I go back to this and say, okay, let's say the n is like number of, I don't know, number of visitors. So something like this. I go back to this and let's say x is some value. Like I know what x is. Like, oh yes, x supposed to represent something. And I go back to here and say, why the heck was this 3? Like, I'm like, I have no clue. Why is it 3? Should it be 3? Is it supposed to be 4? Like, what if I change it to 2? Is it going to break everything? This is the kind of stuff you want to keep in mind. So like this part right here is like, okay, I know n visitors. Oh, number of visitors. That's 5 of them. But maybe something like, okay, like, oh, this is like number of average children each visitor has. Like, oh, person normally has an average of 3. So like, oh, okay, that's what this value is. And that way it's a lot easier to understand, like, oh, this is what it's supposed to be. And that makes it easier for you to change your code. So these are kind of like called magic numbers, where like, instead of doing something like this, you just put like 3 here, and then you come back in a month or a week later or after lunch and you're like, why is it 3? I don't remember why. This will help you in the long run. It seems like it's going to be slower. It seems like it's going to take more work, but do it this way. Trust me. It'll help. You'll thank yourself in the future. Yeah. Okay. Cool. So that's why we made no magic numbers. Also on readability, I don't think I have it on here, is that on readability, comment your code, right? So do you guys all know how to write comments now? Hashtag, octothorpes, #. There's no official name for it, I think. But real fun fact, and then I'll go back to it. Do you guys know why it's called the #? So it's actually because of telephones. But it turns out they had this icon on the telephone and stuff like that, and they put it on keyboards as well. Well, in the UK, we have the pound, right? Or they have the pound, and you don't have dollars. And so it turns out the placement of where that number # was where pound was. So that's why we actually call it, even here in the States, pound. Anyway, hashtag. So make sure you put your comments on here to basically explain your code. Your comments are there to help explain why your code is doing the things it's doing. If you have something like this, right, you want to say, oh, I am, calculating this part, or it's like, oh, this needs to be done in this way. Isn't so much about like your findings. Like, for example, if you do some plot or something like that and you see something, or it's like, oh, I'm interested in this part, you don't need to do that stuff. But in general, your comments are to help explain what your code's doing, like why is it doing this thing. So in general, I would say the more comments you have, the better. I would personally rather read code that has too many comments than too few comments, because it makes it easier for me to know what's going on. Okay. So, and there's no hard and fast rule, in my opinion, about exactly what you should do with comments. Okay. So these are some really basic stuff, but hopefully you guys get an idea. All right, some variables. So variables in Python is, depending on if your background is in another programming language, you can write variables in different ways. In general, you can kind of see how I wrote it is lowercase. If you're having a variable, lowercase with snake case, which means basically separated by underscores. This is the general Python way of doing things. You can also technically write variables like this, like n average children, right? This is called camel case because you have the capitals kind of going up and down. You can technically do this, it's perfectly fine. But in general, Python tends to have the standard of writing it with snake case with underscores like this. And this also works really well for data scientists as well, because then you have like n average children or children average or something like that. And it's a little bit easier to find those parts. You'll see classes, which we haven't talked about here, but classes in general, if you start with a capital letter, it's a special kind of, I won't go into this, but basically there's something called objects and classes, but basically it's reserved for something special. So you wouldn't use this for, you can technically use it for a variable, but tend not to. Always start it with lowercase letters. Constants, usually we tend to do that all capital. So, oops. Yeah, so like, for example, this would be a constant. So like if there is some value that is always going to be the same no matter what, we usually write those in capitals just to emphasize like, oh, this is a constant. But to be honest, even in data science and Python, I still usually see it in lowercase. So less common, but you can technically do it. And this comes from a lot of programming languages as well. Internal use is an underscore. So what's kind of cool is you can actually start things with an underscore in Python. So this could be like this, and that basically is a sign to say, hey, this is not something you really should worry about as a person who's programming it. It's like an internal use variable. So you'll typically see these things like underscore like this. And we'll talk about that maybe when we talk about some objects and classes and stuff. Okay. Make sure your variables have meaningful names. Like, don't just put like, you can see like I just randomly very quickly put X. Try not to use that unless there's a real mathematical reason to use X, or, the famous one is I, or N, or just like A, like A, B. Like you'll see me do this because I can't think of things. I'm not very creative on the fly, but in general, you don't want to write things like this. You want to make it as descriptive as possible so it's easy to understand. Okay, cool. Any questions about variables, readability in general? Sound pretty good? Cool, awesome. Hopefully this is feeling pretty basic and feeling pretty like solid. Like, yes, I'm internalizing all these things. All right, functions. We're going to talk about this about how to write functions. It's not in section 1, so I'm not going to dwell too much on it, but you can actually write your own functions to basically do the same process and over. This is where data scientists, to be quite honest, can be a little like not really write that many functions because we're just used to basically copying cells and moving it over. I will say is that try to make a good practice of functions and we talk about them because they help you not repeat yourself. Basically, if you're doing the same thing, the general rules, like if you do it more than once, like especially if you do it more than twice, you should write a function to do that process. That way you don't have to basically recopy the set of code. And basically that's what a function can do. When you document it, say what it's going to do. We'll talk about this again, but basically make sure you have the good documentation to understand what is it doing, how's it doing it? Because then I showed you guys last time, like shift tab, which is equivalent to like help. It can tell you what's going on. If you document it well, even if it's your own function, you can actually see what it does. And remember, past you is probably going to, or present you, future you is probably going to forget what it did before. So it's nice to have past you / present you actually write all the stuff ahead of time. Okay. Let's see. Use instead of hard coding relationships. Yeah, this is basically same idea, is that if you can write a function that's going to do a certain process, instead of copying the code that's going to do that process, just write a function. Okay. Quick thing in here is security. This is actually, to be honest, this is actually from a previous time where we talked about APIs first before we talk about these things. But we'll talk about this in APIs. Don't code passwords into your code. Do not hard code it. When we talk about this, when you do have passwords and API keys, basically, which are essentially passwords, don't write them in your code directly. We'll talk about how to deal with that, because especially with GitHub, if you're putting your stuff on GitHub and it's public and stuff like that, people can see your code, which means they can see your passwords, which means they can see your API keys and pretend they're you, and do really amazingly horrible things that you don't want to deal with. This happens sometimes, like even in industry, where people will put in passwords, and it's like, oh, like don't do that. I know that there are people who purposely go through GitHub and scrape and try to find where they can find API keys and passwords and stuff like this. And here's the trick too with GitHub, which can, especially for beginners, GitHub and Git is a version control system, which will keep your history. So if you, let's say, for example, you write your stuff, you put your password in there by accident, you save it, you push it, you're like, oh no, I put my password in there. Quick, you delete it, you push it again, and then you look on GitHub, like, ah, it's safe. No one can see my password anymore because I deleted it. That's wrong. You have a history still, and someone can look at your history and then actually find that password still. So if that ever happens, first of all, don't do this, right? As much as possible. Be very careful when you have to deal with passwords. But if this ever happens, the safest thing that I will tell you right now is just make it private at first. Make sure no one can access it, and then figure out what to do from there. It's better to do that than try to fix it really quickly, patch it up, and then think you have it fixed, and then realize you have another security leak. Okay, especially when you're doing like API keys, which is probably a big part what you'll want to protect. Okay. All right, cool. So that's kind of overall those things. Any quick questions about that? Pretty good. All right, cool. So overall view, looking pretty good. Here we have some quick things. We have about 15 minutes left, so we'll see how well this goes and everything like that. Might not get through all of it, but this is basically repeating a lot of what section 1's doing. So some objectives, right? Basically what we want to do is talk about the different data types for variables: strings, numbers, Boolean. There's other ones too, but those are the main ones we're going to focus on. Also floats, right? So I say numbers, but floats and integers and all these things. Data structures. So the main things that we're going to talk about are lists and dictionaries. There's other things, for example, like tuples, which are very specific to Python. But we'll see if we get to that part. And there's things like sets. And then also define use case for different control flow tools. So like if, for, and while. Okay, and those will be very common what you're going to use. In base, these are like the Python basics, like the core Python, the things that you'll use very commonly. Okay, so the first thing are data types. So these are basically just different variables and stuff like this. So I have string 1, or string 2, a number, which is 42.0, Boolean. Remember, we can start with underscore bool like this, equals true. So these are our different types right here, or different variables. We can also have, like, if I have another number, we can do 42, okay? So these all have different types and such, right? So if I actually want to check out this type, what I can do, well, first of all, I can print things out. So you'll notice that if I run this, nothing gets printed out at the very bottom. And that's because Jupyter Notebook's really nice, is that it will run that, and then if there's something at the bottom that's supposed to print out, it'll print that out. So for example, if I put like string 1 equals the meaning of life, and I write this, you'll see that string 1 is right here. This will actually print out the contents of string 1. If I actually comment this out, so it ends basically with just this guy, you'll see that it won't print anything out, because the assignment, which is this guy right here, doesn't actually print out anything. So kind of a nice kind of quirk, nice little feature of Jupyter. So one thing to do is, like, what if we want to check the types? So kind of quick question, does anyone know how we would check the type? Let's say I want to see what the type of number is. Does anyone know how we would do that? I see someone mouthing it.
Yeah, you type. You use the type function.
It's so easy, right? Because of all programming is like this. Type, number, it's a float, right? What about another number? It's an integer, an int, right? And then of course, if I put a string, string, you'll see it is also a string, right? So pretty basic stuff, right? Which is nice. This guy right here, bool, is a Boolean, which I think it just comes out as bool in Python. So Boolean basically only has 2 options. true or false. Note if you have other programming languages, usually you would have this as lowercase, right? But in Python, we use either capital true or capital false. Okay. There's also another special variable in Python called none or type. So you can actually see the none right here, none type. So this is kind of like this extra special guy. There's certain things we can do with our variables and stuff like this. For example, we can do things like we can add numbers together. So if I do number plus another number, we can actually have a new number, right? Note that basically floats and integers can interact together. But if I put something like this, do you guys know what's going to happen? Only one way to find out. Type error. So you can see here, this error says, hey, type error. You can't do this. You can't add a float and a string together, okay? So let me ask you guys, can we add strings together?
Concatenate. Yeah, concatenate.
Yeah, concatenate, right? Awesome. So this is basically, strings are really interesting objects that we can kind of deal with and stuff like this. What if we put like none? Can we add this together? Nah, no, right? So this is where you start learning a little bit like what works out. And this is where we see that error here is giving us information about what's going to work, right? And honestly, if you don't know, try it out, see what happens, okay? You're not going to break it, most likely. All right. So some string methods, I won't go into full thing, but you can do things like uppercase, which will make it all upper, dot lower, which will make it all lower and stuff like this, capitalized, title. Title will actually space it out. So you can see here like title for string, I don't know what string is. What is the meaning of life? You'll see that each word is capitalized at the beginning. So useful stuff. There's other things you can do too. There's a whole bunch of different string methods. And note that I had to do the variable and then dot the method that's on here. So since we use strings a lot, this is something that can come up a lot. F strings. This is not mentioned in the curriculum, but does anyone know what F strings are in Python? I'll tell you what they are. They are amazing. So what you can do is, let's say, for example, I want to do, what was that number? We had number. I have this number, right? And I want to say something like, hey, like, let's say I say, what is the meaning of life, right? And I want to say, hey, 42, right? It's like, oh, it would be really cool. Like if I had the string, let's say, I'm going to just add a little cell here. Let's say I have like n string is equal to 42. I could just do, let me run this guy. I could have just done this, right? 42, oops. I'm going ahead of myself. N string, and that would be like awesome, right? But let's say like, you know, I don't want to define this new thing. I want to be able to use, let's say, number, right? I can't just put number here. You're like, that stinks, right? So one thing you can do is actually what we call casting. You can change the type of this. So when we can change something into a string, we can just do str, oops, str, and you'll see that it turns green right here. So actually if I go like this, you can see it turns green. That means basically, hey, this is a special word in Python. So string here, str is a special word in Python. And we can actually use this to cast our number. We can cast our number into a string. And now we can get 42. Hey, awesome, right? But you're like, you know what? I'm really lazy. I really don't want to do this, right? So there's even better way we can do this. So one thing we can do is we can convert this number into a string using f strings. So note that if I do like this, is this going to say 42 at the end? Yeah, I see some head shakes. No, it's going to do a number, right? But with f strings, what I can do is I can do f and say, hey, this is a special string. And I can put curly braces around this. And this basically tells Python, hey, treat this as a string in there. So whatever that's supposed to be in there, figure that out, give me back a string. And you can see this nice, amazing thing right here. And what's really cool, it's like, well, okay, this is kind of annoying. I don't like this plus 5. It's like, okay, fine, Victor, we can do something better. We can actually say, hey, this is whole thing's an f string. What is the meaning of life? Number, really easy to read. And this will actually print out exactly like this guy. So these are really useful. You can even do things like add those code inside here. So you can do some very quick things with their strings. This is the preferred way now. Note that I think it's 3.7 on Python, which you guys all should have. It might actually work in 3.6. I can't remember exactly, but at least 3.7 for sure. The newest version of Python, do you guys know what the newest version of Python is by chance? 3.8, so they have a new version. So you should be pretty safe now. For the record, Python 2.0, which you guys should not be using and stuff like that, that's done now. It actually officially ended January 1st this year. So don't use Python 2. You might still see people use Python 2, but know that's on its way out, basically. All right, so anyway, this is some string stuff. Sound pretty cool? Any questions? Cool. All right, so I only have 7 minutes, so I know I'm not going to be able to get through everything, but I'm going to show you data structures next. Okay, so some first things is our main data structures I'm going to talk about are lists, which are very, very common that we'll use a lot in data scientists, and dictionaries, which will be really useful, especially when you use APIs and JSON objects and stuff like this. I shouldn't say JSON objects, but using JSON. So list, right? So our list basically is a way to list out our information like in Python. So if anyone who's been doing other programming languages, this would be close to what we would say like an array is in other programming languages. It's a little bit different because Python's very, very forgiving, which is super, super nice, but also can cause you a whole lot of pain. So you'll notice that this top travel cities, and I have Salta, Greenville, and all of these different, cities, right? And I go ahead and let's just do top travel cities. You can see I can go ahead and print out this list of cities. Ooh, how nice, right? Now, one thing I'm going to point out is that, can I put like just the number 1 here? Does anyone know? Like, will this give me an error? Will this work? Yeah, good. You guys are smart. You guys are sharp on top of this. Yeah, you can put whatever you want in a list. In fact, you can even put like list within lists. So like I could even do something like top travel cities like this, and you'll see there's a list within a list. So lists could basically contain pretty much whatever you want in it. Okay, cool. So now I want to show you guys about how to actually basically pull out elements in that list. So what's nice about lists is that they have an order, basically. There's the first element all the way to the last element. So we can do some really nice things. For example, we can actually pull out the very first element. So note that we start with the number 0 when we're counting. And usually, I would say in programming, but there's some programming languages that don't do this, but starting off with 0. So this will pull out the very first element, which is Salta. Cool, right? Ooh, exciting. I'm actually gonna get rid of this because it's gonna cause me some issues. There we go. I can also pull out the second element, which is the number 1. Ah, how nice, right? What if I want to pull out the 10th element? Or I guess this is the 11th element. Nice, right? Oh, did I run this over again? All right, I'm trying to make, that's about the 21st element. Ah, index out of range. So note that basically I can't pull numbers that are not there. So one thing you can do is like, okay, what if I want to know how long this list is? Well, what I can do, I can check out. Does anyone know how to check how long the list is in Python? Okay, I see some people. I saw Jessica do Len, like voice it out. Yeah, feel free guys to, unmute yourself and answer, right? Len, right? So Len will show you it's 11, right? I thought I had less than 11. I didn't realize it was that long. But you can see here, this index will say, okay, so if I want the very last element in here, I just do len of top travel, right? That'll work fine. Yeah, right. Ah, because we start with 0, we can't have that. So we have to -1 here. And you're like, oh my gosh, look how ugly this is. Like, just say, ugh, gross, right? So there's actually a really quick way we can reference the last element. In fact, just do -1. Yeah, I saw Alvaro. Cool, right? And what's cool is what if I want the second to last element in there? -2. So now we can kind of count backwards and stuff like that. So it's really nice to be able to count forward starting with 0 and also counting backwards from -1. Okay. Note if I put in something like -20, which is like the 20th from the back, it's not going to work. Okay. Sound pretty good? Cool. All right, this is where we can also talk about slicing. So you can see here in Python, and this is going to be very common when we start doing NumPy or using NumPy arrays and stuff like this. But Python has this really amazing thing that you will miss. If you ever go back to another programming language, you're going to miss slicing so much. But what we can do, we can actually pull out, let's say, okay, let's go from the first element all the way to this. Well, it's going to be the 5th element in here because this is actually going to exclude the 5th element. So that's 0, 1, 2, 3, 4, 5. It's not going to include Albuquerque. Okay. So if I do this, you can see it gives me a whole list up to here. Oh, nice, right? We can also say, okay, I don't want to start from the beginning. I want to start from here, right? If I want to start from the beginning, I have to put the 0 in here. I can just exclude 0. And now I'll just say, hey, from the beginning to here. If instead I want to say, oh, let me start with the 6th element and go to the very end, I just exclude that part there. And you can see I get everything from the 6th element, which is Albuquerque, all the way to Tianjin. Cool. And you can see a little bit of some examples in here. Any questions so far about this? Pretty good. All right, I do have to head on a minute. Let's see here. We'll continue this for next time. I'll keep this for this. But one kind of quick thing I want to show you guys. What if I go 0 to 5, which we saw was this right here. And I'm going to make a copy. What if I do this right here? Does anyone know what that does? Yeah, tricky, huh? Right. It actually turns out, like, it's like, wait, what's going on? This will actually, so these will basically grab the first 5 elements, but it was going to read it backwards. Oh, wait, never mind. I need to do it this way. There we go. I did it backwards, that's why. There we go. So note that basically this should read things backwards in here. So for example, if I want to reverse lists, a really easy thing to do, this will just grab the whole list, right? If I do this part, -1, this will actually read it backwards. Another thing you can do too, is what I should have done first, 0 to 5. You can also count by 2s. So this will actually start from the 0 and go by 2. So you can see it's every other one. So some nice things you can do. You can also do things like -2. Oh, that's not going to give me. You can also count by 2s backwards. So you can do some really fun, interesting things with slicings and stuff like that. You'll see these kind of like structures used a whole lot. All right, cool. So that's a little quick thing I wanted to show you guys. We may talk a little bit more about list methods, but if you go through section 1, you'll get through this, get this part. I'll mention about dictionaries next time, and control flow, you guys, again, reading through section 1 and everything like that. Okay, and if you have these parts in there, you should be able to do the Macbeth project thing. I know that one can be a really big like project as like, note that it's not like you have to turn it in or anything like that, right? So don't stress out about like, oh, I need to turn this in or something. But I know that project in particular can get to students who are like, oh, this is a lot of work kind of deal. But it'll help you practice a lot about navigating through strings and going all through that part and doing different control structures. Okay, so we might go over that maybe next study group next week.